Mole concept and molar mass. So mole concept, mole in general is one of the concepts that many students find it very hard, but I don't know why, because it's one of the simplest concept in chemistry and we're going to use it a lot. Okay, so let's learn what is mole. So what is mole? So if you remember when we were talking about atomic mass, we said it's the unit was AMU, and that was a very tiny unit, and it was 1/12 of carbon 12 atom. Okay, so if you have carbon 12 atom, 1/12 of that is 1 AMU. Now we are in the mole world. Okay, so what is mole? Mole is number of atoms in exactly 12 gram of carbon 12. Okay, so if you have 12 gram of carbon 12, how many carbon 12 do you have? That number is mole. Okay, you have to remember this is a number. Okay, mole is a number. So when you have this number, you have a mole. Just like a dozen. It's pretty simple, right? When someone tells you we have a dozen of donuts, you know you have 12 donuts, right? You don't think about, I don't know, 11 donuts or 13 donuts. You know it's 12, right? Mole is exactly the same thing in chemistry. Okay, when you say you have 1 mole of this thing, you have this number of that thing. It's exactly that. So it's just a counting unit. Okay, just like a dozen. When you count something and say a dozen of donuts, it means it's 12 donuts. Mole is exactly the same thing in chemistry, except it's a very large number. Okay, so a mole of something is 6.022 times 10 to 23rd number of that item. Okay, so 1 mole of carbon 12 is 6.022 times 10 to 23rd carbon 12 atom. Okay, and the mass of 1 mole or this many carbon 12 atom is 12 gram. Okay, so this number is called Avogadro's number. So what is molar mass? Molar mass is the mass in gram of 1 mole of anything. Okay, so if you think about what we said in the previous slide, what is the molar mass of carbon 12? Well, yes, it's 12.000 gram, and that's how we show it. The unit is gram per mole because that's the mass in 1 mole. So that's gram per mole. So as we said, molar mass is a gram of 1 mole of, we say units. Oops. Okay. So we say units, and that could be atoms or molecule, or it could be anything. When we say we have 1 mole of carbon, it means we have Avogadro number of carbon. If we say we have 1 mole of water, it means we have Avogadro number of H2O molecule. Okay, so it's just a counting unit. It could be applied to anything. It could be applied to atoms, to molecule, to ions, to even apples. Well, but it doesn't make sense because just think about if you have Avogadro number of apples. I think that would cover the planet Earth. Okay, so we use mole for very small things, but I want you to get the concept. It's just for counting things, and it's for counting very small things because it's a very large number. Okay, so mole is a number. Okay, molar mass is the mass of that number of anything. Okay, so if you have Avogadro number of, let's go back to our apple example. If we can use Avogadro for apple, the molar mass for apple, that would be the mass of Avogadro number of apple. That would be tons of kilograms. Okay, so that would be the molar mass, the mass of 1 mole of anything. Okay, so what is the molar mass of carbon 12? We said that in the beginning when we were defining the mole, we said that's the number of 12 gram of carbon 12, right? So if the definition of mole is the number of carbon, of 12 gram of carbon, so when you have 1 mole, you have 12 gram, right? So the molar mass of carbon 12 is 12.00 gram per mole. And the number, so maybe I had to say this in the previous slide. So when we were defining the mole, we said 12 gram of carbon 12. How many do we have? We have Avogadro number. And they came up with a number not with just counting them because you cannot count the atoms, but experimentally they came up with the number that it should be this number of carbon 12 atoms. Okay, so molar mass of carbon 12 is 12. Molar mass of just carbon, so we know we've learned about isotopes, and we know that all carbon are not carbon 12. We have carbon 13, and the molar mass of carbon is 12.1. Okay, so you see the numbers that you see in the periodic table as AMUs is also the number for the molar mass, because it's 1/12 of carbon 12, and 12 gram of it is 1 mole, so it's just become the same number. Okay, so if you have 1 mole of that thing, you have the atomic mass gram of that element. Okay, so the molar mass in grams of any element is numerically equivalent to the atomic mass in AMU for one atom. Okay, it might be a little bit confusing at this time, but if you think about it just like a dozen, that's how it sticks to my mind. So as simple as you define a dozen, that a dozen is 12, the same concept goes to the mole. So Avogadro number of anything is 1 mole. Avogadro number of carbon is 1 mole of carbon. Avogadro number of H2O is 1 mole of H2O. Avogadro number of apple is 1 mole of apple. Okay, but you have to think about it. So since mole is a number, it's not mass, right? Just think about baseball and soccer ball. Okay, so you see the size and the mass is different, right? You might say you have 5 basketball, for example, and 5 baseball. Okay, both of them are 5, right? But you see basketball, 5 basketball takes up a lot of space and is heavier than 5 just baseball. Okay, molar mass is also the same concept. So you might say a mole of carbon or a mole of water. Okay, it means that in both of them you have Avogadro number of carbon and Avogadro number of H2O, but the mass might be different because each unit have a different mass. So 1 mole of carbon is 12.01, 1 mole of water is 18 gram. Okay, so the mass might be different, and that is called molar mass, the mass of 1 mole, but the number is the same. So when we are talking about mole, we are talking about number of items, number of units. So here is the summary of what we just said. So 1 mole of atoms is Avogadro number of atoms, and we write atoms, but it could be anything else, molecule, ions, apples, anything. So 1 gram is Avogadro number of AMU. Okay, so if you think about it, 1/12 of carbon, so that's if you have Avogadro number of that makes it a gram. That part might be confusing, but that's how it is. Okay, 1 atom of carbon 12, 1 atom is 12 AMU, because that's the definition of AMU. 1 AMU is 1/12 of carbon 12, so 1 carbon 12 is 12 AMU, and 1 mole of carbon 12 is 12 gram. Okay, so that's the summary of what we just said. Okay, so we had a lesson about dimensional analysis, about process of converting between units. And we are going to use this concept in our mole concept. So you have to learn how to use the molar mass. If you remember, we said whenever you have a unit that is in ratio, for example, we talked about density in dimensional analysis, right? And we know the unit is gram per milliliter. It could have different units, but that's one of the units, okay? So when you have a unit that is in ratio like this, you can use it as a conversion factor, which means, for example, if density is 7.8 gram per milliliter, it means if you have 7.8 gram, it is equal to 1 milliliter, okay? You can use the same concept with the molar mass. The unit for the molar mass is gram per mole, right? Which means if, for example, water, it has the molar mass of 18 gram per mole, it means if you have 18 gram of water, H2O, it's 1 mole of water. You have to be careful. This should be about the same compound or element, okay? So if you're talking about gram of water, it's the mole of water. It's the same thing. Or if you have 12 gram of carbon 12, you have 1 mole of carbon 12, and you can use it as a ratio. And since they are equal, this ratio equal to 1, and that's the basis of using these factors in our dimensional analysis, because they're equal to 1. So the numerator and the denominator should be equal. And the molar mass was not the only one. So as I said, in the dimensional analysis, you can use any equality as a conversion factor. Wherever you see two things are equal, you can make it as a conversion factor. Like what? We know that Avogadro number times 10 to 23rd number of anything equal 1 mole of one thing, right? That's what we just said. Just like a dozen is 12, 1 mole is Avogadro number of anything. So since they're equal, I can make a conversion factor out of it. So Avogadro number equal 1 mole. So we can make a ratio out of it. Or 1 mole is Avogadro number, right? So I can also use that as a conversion factor. And I know that these two, the ratio equal to 1, right? So 1 mole of carbon 12 is Avogadro number of atoms of carbon 12. You can replace carbon 12 with anything else, and as we said, since mole is just for counting, you can do it for carbon, you can do it for oxygen, you can do it for hydrogen, or you can do it with apples, okay? It doesn't matter. So it's just for counting. So these are the conversion factors that we talked about. So 12 gram, we're just, for our example, we're talking about carbon 12, but it could be anything else. You just have to, if you use, for example, if you use oxygen, then this would be, what is the mass of oxygen? It's 16, okay, 16 point something, I don't remember, but it's 16. Oh, to be exact, it's 15.998, okay? So 15.998 oxygen is 1 mole of oxygen. You have to find the molar mass, and you can find it from the periodic table, okay? So we have our conversion factor. 12 gram of carbon 12 is 1 mole of carbon 12, and 1 mole of carbon 12 is Avogadro number of carbon 12, okay? So with these two, we can go from gram of element. If you have the gram of element, we can use the molar mass. Where can you find the molar mass? Periodic table. You can find the molar mass of that element, and then you can go to mole. And if you want to know how many of that atoms you have, you can use Avogadro number, and then you can see how many of that element you have. So let's do some examples so we can better understand what do we mean by these. So how many atoms are in 10 gram of oxygen, okay? So you know oxygen is, elemental oxygen is always diatomic, O2, but let's just think about just oxygen atom, okay? So as I said, in the dimensional analysis, you always start with what is given the information, given information in the question, okay? So we have 10 grams of oxygen. Okay, I want to know how many atoms. Basically counting every single atom and see how many do we have. Okay, so from gram to how many, we cannot go there. When we say how many, it's counting. So I know the unit that refers to the counting is mole, right? So first we have to go from mass to mole. And what is the quantity that we can use to convert mass to mole? It's the molar mass, right? So we have gram on here, so we want to get rid of that. I put gram on the bottom. So gram of oxygen and mole of oxygen. Okay, and you can find the molar mass of oxygen in the periodic table. It's 15.998, but I just write 16 here. So 16 gram is 1 mole. Okay, we are not done yet because we have mole. It says how many. We want to know how many single atom do we have. From the definition, I know that 1 mole, and mole is on the top, so I put the mole on the bottom to get rid of that, mole of oxygen. And from the definition of mole, I know 1 mole is Avogadro number of that element, which is oxygen in this case. Okay, so 1 mole is Avogadro number. Okay, so are we done now? We can cancel gram with gram, mole with mole, and I end up with the number of elements. Okay, and that's what the question is asking, how many. Okay, so we are done. So the rest is you just put these numbers in the calculator, and that's 3.764 times 10 to 23. And if I want to care about my sig figs, so I have 2 sig figs here because I could have more. For my molar mass, it's 15 point something. I just made it to 16, so I have 2 sig figs, so I have to round it here. So it's 3.8 times 10 to 23 atom or oxygen atom. Okay, so I have this number of oxygen atom in 10 gram of oxygen atoms. Okay, so next example, let's give you some, you can pause and take some time to answer this question. What is the mass of 1 mole of aluminum? Well, this one is easy because it's actually the definition of the molar mass, right? Or I can write it, so let's write it. So say 1 mole of aluminum times, so from mole to mass, what is the quantity we can convert mole to mass? That's molar mass. So I want to get rid of mole. I write mole here, mole of aluminum, and gram of aluminum, and the molar mass is 26.982 1 mole. Okay, so you can get rid of mole with mole, and it's 1 and it's 1, so the same number. So the question was the definition of the molar mass. So basically when we say gram of aluminum, when we say molar mass, we mean 1 mole of that item. And the question is asking the same thing. What is the mass of 1 mole of aluminum? It's the molar mass of aluminum, right? Okay, so let's do some more example. What is the mass of 1 million atoms of iron? Okay, so here we have number of atoms. We want to find the mass. Okay, from number of atoms, where can we go? We can go to the mole of atom, and from mole we can go to the mass. Okay, so let's do that. So 1 million is 10 to 6, right? So that's 1 million, 10 to 6 atom of Fe. Alright, okay. So we want to go from atom, from the number to the mole. So we use the definition of the mole, Avogadro number. Okay. So the number of atoms is on the top, so the number of atoms should go to the bottom, and the number is Avogadro number 10 to 23 Fe is 1 mole of Fe. Okay, so we're not done yet. We want the mass. We don't have the mass, we have the mole. So to go from mole to mass, what quantity do we use? The molar mass. So we have to use the molar mass of iron from the periodic table, and that is so we write the mole here, and we want the gram here because we want to get rid of mole. So 1 mole is 55.845 gram. Okay, so now you're done. This is the number of atoms with number of atoms, mole of iron with mole of iron. We end up with the mass of iron, and that's what we want. We want the mass of iron. Okay, so then the unit is gram of iron, and that's good. So we want the number, so we have to put these numbers in the calculator and see what is the mass, which is 9.2735 times, oh, I have to erase this part. So let's erase this. I have to make a larger one, but anyway, so times 10 to negative 17 gram of iron. Okay, so let's have another example. So you tell me this one. How many moles are in 62.5 gram of helium? So you start with 62.5 with the given information, gram of helium. We want moles, so we have mass to mole, and what do we use for conversion between mole to mass? Molar mass. So we have gram, I want to get rid of gram, so gram of helium, and that's a gram of helium. Gram of helium here, so we can cancel it, and on the top I write mole of helium. You can look at the periodic table and see what is the molar mass of helium, and you know it's 4, so 4 gram of helium is 1 mole of helium. Okay, so you can so therefore you can cancel gram with gram, and you have mole of helium. So in the end you have mole of helium, and you can use your calculator. I'm doing it right now to do the division. So 15.625 mole of helium. Mole of helium. Okay, so let's see our next example. Okay, so we don't have example. So as I said, we can use these units as a conversion factor. So we are going to make a toolbox for our unit conversion. Okay, we have at this point several tools. We know that we can use it for converting, and we are going to build more and add more to it. So for gram to mole, let me change the color. From gram to mole, we use molar mass. Okay, from mole to the actual number of each unit, we use Avogadro number. If you're going to change from gram to milliliter, this is from chapter 1 that we talked about, the mass over volume, its density. We can, if you want to go from gram to milliliter or mass to volume, use density. If you want to go from gram to kilogram, or as an example, we use the prefix meaning. We want to go to milligram to gram or millimeter to meter, we can use those prefixes and use it as a conversion factor. Okay, so now think about the definition of molar mass, and think about my example of baseball and soccer ball or basketball. See, think about that mole is number and mass is different. Molar mass is the mass of 1 mole. So answer these questions. Which one of these have more number of atoms? Okay, so to answer that, you have to check the molar mass of each of these three, and I'm going to write these three molar mass for you. Okay, so these are the molar masses of these three elements. Okay, gold is about 200 gram per mole, aluminum is 27 gram per mole, and neon is 20 gram per mole. Okay, so let me give you this example so it can help to answer this one. So if you go to the grocery store and get a pound of blueberries and a pound of watermelon, okay, which one do you have more number of them? Do you have more number of blueberries or more number of watermelons? Okay, a pound of a watermelon is not even one watermelon. It's definitely way more than a pound. But blueberries, you will get, I don't know, hundreds of them or maybe more, I don't know, but you get more. So if each unit have have a smaller mass, is weighing less, so you get more of that, right? So neon have the molar mass of 20 gram. So it means if you have 20 gram of neon, you have Avogadro number of that. Okay. If you have 20 gram of aluminum, you have less than Avogadro number because it weighs more. And gold is a very heavy element. It's about 200 gram. Okay, so if you have 20 gram, it's 1/10 of Avogadro number. Okay, so which of these atoms do you have more? So we definitely have more of the element that has a smaller number as the molar mass. Okay, so you have more of neon. So pause here for a moment, think about it, let it sink. So the element which is lighter, if you have the same mass of 2 or 3 elements, the one which is lighter, you have more number of that. Just like if you have 5 pounds of blueberries and 5 pound watermelon, you have more number of blueberries because each blueberry weighing just, I don't know, about a couple of grams. Okay, it's so lighter than the watermelon. Okay, so the element that has smaller molar mass, it means it weighs less than the other ones. You have more number of that element if you have the same number of mass. Like if you have 14 of all of them, you will have more neon. Okay, so we are going to add one more conversion to our toolbox, and we are going to finish this video. So when we have a molecule and we want to know how many atom is in that molecule. Okay, for example, we have CO2. If I ask you how many oxygen is in this mass of CO2, okay, so you have to think about, well, we already thought about gram and mole. How do we convert it? Molar mass. So if you have 1 mole, you have 44 gram of CO2, and then from mole you can go to the number of molecule because we are talking about mole of CO2, therefore it's number of CO2. It's the number of molecule. So Avogadro number of CO2 is 1 mole of CO2. But how many oxygen? So in 1 CO2, how many oxygen do we have? We have 2, right? The subscript tells us how many of that element we have. So in 1 CO2 is O2, so we have 2 oxygen. So we have 2 atoms of oxygen in 1 molecule of CO2. If the question was how many carbon atom, then it was 1 carbon atom, 1 atom of carbon in 1 molecule of CO2. Okay. If I ask you how many total atoms do we have? We have 1 carbon and 2 oxygen, so that makes it 3 atoms total. Okay, so that would be 3 atoms in 1 CO2 molecule. okay? So you have to look at the prefixes and see how many atoms you have. So let's have one example so we know what we are talking about. So how many hydrogen atoms are in 5 gram of H2O? Okay, so we have 5 gram of H2O. First we can go from mass to mole, and gram is on top, so I want to get rid of that, so I put gram here and mole on top. So I know 18 gram of water, and this is gram of water, right? H2O, and mole of H2O, okay? So 1 gram of water, 18 gram of water is 1 mole. Then from mole, we can see how many do we have. So it's mole of H2O. Remember, mole is counting unit, and it matters what unit we are talking about. So I write the subscript H2O because I'm talking about how many H2O I have. Because in our previous conversion factor, we had gram of H2O and mole of H2O. You cannot say 1 mole of H2O, Avogadro number 23, Avogadro number of hydrogen. You cannot do that. No. You should say Avogadro number of H2O because you were talking about the mole of H2O, okay? Okay, are we done? No, because the question is asking how many hydrogen atoms, not H2O molecule, okay? Okay, so for 1 H2O, how many hydrogen do we have? It's H2, right? So we have 2 hydrogen atom, okay? Are we done? Let's see. So we have gram of water, mole of water, water molecule, and we end up with hydrogen atom, number of hydrogen atom. And the question is asking how many hydrogen atoms. So we are good with the units, so the rest is just putting these numbers in the calculator. So it's 3.346 times 10 to 23rd, okay, hydrogen atoms. Okay, so we have this number of hydrogen atoms in 5 gram of water. Okay, so I hope you get to know how you can do these problems. We're going to have more example in the recitation, so you have better practice.